Good morning students, welcome back. I hope yesterday I have taught medians and altitudes that you have understood. Okay, now yesterday we have seen triangles based on the angles, that is acute angle triangle, right angle triangle and obtuse angle triangle and their altitudes. Okay, and the point of concurrence where it lies. Now we are going to study equilateral triangle and isosceles triangle. Scalene triangle, there is no any such speciality about it, because all the altitudes they are going to be, any general triangle you draw, they are going to be in the interior of the triangle only. For isosceles and equilateral also, they are going to be in the interior, but they have got certain specialities. I'll tell you. So let us draw first isosceles triangle and let us see what is the speciality of the altitude of the isosceles triangle. Okay. So I have drawn the isosceles triangle here and this is the equilateral triangle. Now let us draw the medians. Okay. Altitudes. Let us draw the altitudes. Okay, so this is exactly 90 degree. Now here okay, and this is the altitude here, and this is the another altitude. But if you see this altitude, is it exactly intersecting the opposite side in the center? Check it. Yes, it is. If you measure it with the help of scale, now I have got this length as 6 centimeter. So exactly in the center at 3 it comes. So what it suggests, that one altitude is same as the median. Do you get it? That is the speciality of isosceles triangle. So one altitude is also the median of the isosceles triangle. Now which is that? That is the line segment which is drawn from the vertex on the non-congruent side. These are the two equal sides, or these are the two congruent sides of isosceles triangle. So which is the median which is also altitude, or which is the altitude which is also median? That is the line segment which is drawn from the vertex on the non-congruent side is the median as well as the altitude. So I will write here. Okay, the line segment drawn from the vertex on the vertex to the opposite non-congruent side is the altitude as well as the median. So there is one median, which is also the altitude. And which is that? It is the line segment from the vertex on the non-congruent side. Okay. Now let us go for equilateral triangle. Now for equilateral triangle, okay, this is my first altitude, this is my second altitude, and this is my third altitude. Now if you see them, if you measure, let us measure here, this, you will see that they are congruent. Okay, you can see here. Actually this total is 8 centimeter, I have got it at 4 centimeter. This is 8 centimeter, I have got the altitude at 4 centimeter. This is 8 centimeter, altitude intersects the segment at 4 centimeter. What it suggests? That the altitudes of equilateral triangle are also the medians of the equilateral triangle. They are also the medians of the equilateral triangle. That is the speciality of equilateral triangle. So here we can say all the three altitudes of equilateral triangle are also the medians of the triangle. So that is what the speciality of these two triangles is. Okay. Now, that thing discuss and write. Page number 115. So first question, how many altitudes can a triangle have? 3. That is the answer. Second, draw rough sketches of altitudes from A to BC for the following triangles. I think you can do that. I have shown how to draw them. Okay. Third, will all altitude always lie in the interior of a triangle? No, they will not lie always in the interior of the triangle. And the reason I have told you yesterday, I have drawn obtuse angle triangle, acute angle triangle and right angle triangle. And for obtuse angle triangle, what happened? The altitude was outside the triangle. Two altitudes were outside the triangle. That is, the point of concurrence was also outside the triangle. Okay. Then, can you think of a triangle in which two altitudes of the triangle are two of its sides? So yesterday only we have seen that for right angle triangle, the two sides which form the right angle are the altitudes of right angle triangle. So that is the answer. I hope you will write it down if you have not written. And now last, can the altitude and median be same for a triangle? Yes, they can be same. For isosceles triangle, the line segment drawn from the vertex to the opposite non-congruent side is the altitude as well as the median. And for equilateral triangle, all the three altitudes of equilateral triangle are also the medians of the triangle. So you will draw these two figures. Okay. So that is what the answer for the fifth question. Okay. Now do this. Take several cuts of equilateral triangle, isosceles triangle and a scalene triangle. You find their altitudes and median and you will find something special about them. Discuss with your friends. You can discuss it, the friends which are in contact with you on your phone. Okay. Already I have told it here. Do the cuts and try them. You will get this same property. Okay. Now let's move to the next part, that is exercise 6.1. Okay. Now exercise 6.1, question number 1. So this is the triangle PQR. PM is, oh yes, see the 90-degree sign, it is altitude. And PD is, you measure this, you will come to know, it is, yes, there you are, it is the median. Now the next question is QM is equal to MR. This is QM and this is MR. Are they equal? Not necessary, they are not equal. Why? Because this is altitude. Altitude does not divide the side into two equal sides. Hence QM is not equal to MR. So So here we will say no. QM not equal to MR, because PM is the altitude. Okay, so that is what the answer. Now question number 2 is you have to draw the rough sketches for the following. So you can do that, okay, and I have told how to do them. Then question number 3, verify by drawing a diagram if the median and altitude of an isosceles triangle can be same. So I have shown it before this, okay, for isosceles triangle. So you do draw that again, right? Now let us move to the next property, that is exterior angle of a triangle and its properties, okay, and its property. Now see, dear students, before coming to the exterior angle property, let us study what is meant by exterior angle first. Suppose this is the triangle, and suppose if I extend one of its side, so this is triangle ABC, okay, and I have extended side BC, and this is point D on it. Now this angle ACD is the neighboring angle for angle ACB, right? It is the neighboring angle for angle ACB, and this angle ACD is called as the exterior angle of angle ACB. Keep this in mind, this angle should be always in linear pair with this angle ACB. Okay, so this angle ACD is called as the exterior angle of the triangle. Now there is one property of this exterior angle, that the measure of this exterior angle is equivalent to the sum of its interior opposite angles. That means these two angles. Okay, so these are called the interior opposite angles or remote interior angles. They are also called as remote interior angles, or remote yani which are away, which are far away. Okay, so here these are called as interior opposite angles, and the sum of these two angles, measures of this sum of these two angles should be equal to this angle. That is the property. So how you can do? Okay, so for that what you do? What I have done, you can do this activity, draw two triangles of the same measure. These are identical triangles. The only thing is, for this triangle I have drawn one exterior angle. Now what I am going to do, I am going to cut this angle at this particular marking and this angle at this particular marking, and then I will place them here. Let us see whether I get the same measure. Okay, so I have shown you. Now I will cut this. Okay. So dear students, what I have done, I have cut these corners, angles. Okay, now I have colored them so that you can identify them. Okay, so you can see here both the angles, they exactly fit in this particular angle. So what it suggests, that the measure of these two angles which were here is exactly equal to this exterior angle. Okay, so both have exactly fitted into this, suggesting that the measure of the exterior angle is equal to the sum of measures of its interior opposite angle. So that is called as the property of exterior angle, or it is also called as exterior angle property. Now you can do this activity. Definitely, surely you will enjoy it and you will understand the property very well. And the other way you can do it is, what do you do? Measure this angle A, measure angle B, and then measure angle ACD with the help of protractor. Till you don't make mistake, you will always get the sum of these two angles. You will always have angle A plus angle B equals to angle ACD. Try it. Do these activities. Okay. Now let's move to the next part. That is we can prove this statement. That is, we have got a proof for this. So for that, the statement is an exterior angle of a triangle is equal to the sum of its interior opposite angles. So we can give the logical step by step proof for that. Okay, so what I will do, first I can draw the triangle. So this is triangle ABCD and this is AC. Okay, this is angle 1, this is angle 2, and this is X and this is Y. So what is given? What is given? It is given that in triangle ABC, angle ACD is an exterior angle. What you have to show or to prove, you have to prove that major angle ACD is equivalent to major angle A plus major angle B. Now let us go for the logical proof. So for that you have to do one construction. Draw a ray CE parallel to segment AB from C. Okay. Now you have studied parallel lines and its transversal and its properties. Okay. So first, angle 1 is equal to angle X. Angle 1 is equal to angle X. Why? AB parallel to CE, AB parallel to CE and AC as transversal. So what type of angles they are? Oh yes, they are alternate angles. Okay, so they are alternate angles. Then similarly, angle 2 is equal to angle Y. Now how? See here, AB parallel to C and BD as the transversal. So what type of angles they are? They are corresponding angles. Exactly, they are corresponding angles, and so they are congruent, right? So here we can say AB parallel to CE and BD as the transversal. And they are corresponding angles. Okay. Now what do you do? Add step 1 and 2. So third. So I am adding step 1 and 2. So angle 1 plus angle 2 is equal to angle X plus angle Y. Adding 1 and 2. Add 1 and 2. Okay. Now angle 1 plus angle 2 means angle A plus angle B. Exactly. So step 4. Angle A plus angle B. That is equal to, and angle X plus angle Y means angle ACE plus angle ECD. and that is means what? Angle ACD. Okay, so I can write here angle ACE plus angle ECD. Now angle ACE plus angle ECD is nothing but this whole angle ACD. Okay, so therefore angle A plus angle B is equal to angle ACD. So what do you got? That what we got? We got that the sum of interior opposite angles is equal to its exterior angle. Okay, and so further you can write hence the proof. This is also called as the theorem. In 9th standard you will study this as theorem, logical statements to prove them. Okay, and I hope you will write down this logical step by step argument in your notebook. Okay, because this can be asked in exam. It is there in your textbook, but it is expected that you should know that, and so I request you to write down in your notebook. Okay, so think, discuss and write. First one, exterior angles can be formed for a triangle in many ways. 3 of them are shown here, figure 6.10. So 3 of them they have shown. There are 3 more ways of getting exterior angles. Try to produce those rough sketches. So we will draw them. Okay, so think, discuss and write. Page number 117. Think, discuss and write. Page 117. Okay, so 3 of them they have given. So we will try to write 3 more. So this angle is not given. Okay, then okay, and this. Do you get it? So these are 3 more ways in which you can get the exterior angle. Okay, for a triangle. Now question comes, then how many exterior angles are there for a given triangle? So you should know that. Okay, that is not discussed in the text here. So suppose this is the triangle. So I extend this side. So 1. This is the exterior angle, right? I extend this side. So this is another exterior angle. So 2 at the vertex. Then this is 3rd. And this is 4th. Right? And this is 5th. And this is 6th. So how many exterior angles are there? There are 6 exterior angles. How many? There are 6 exterior angles. Okay, then question comes, are these exterior angles this? No. Why? Because they are vertically opposite angles to the angles of a triangle. They are not in linear pair. First one they have said. Which is the exterior angle? The angle which is in linear pair with the angle of the triangle. Here this is not in linear pair, it is vertically opposite angle. Hence it is not exterior angle. Only these 2 are exterior angles because they form the linear pair. You know linear pair, which has got common arm. And the outer 2 arms, the opposite rays. Okay, and the sum of the angles is, yes, 180. Okay, so they are linear pair angles, right? So now, so there are 6 exterior angles. One more speciality. The exterior angles at each vertex, they are always congruent. So means what? These 2 angles, they are congruent. These 2 angles, they are congruent. These 2 angles, they are congruent. Why? Again, they are linear with the same angle, na? They are in linear pair with the same angle. So their measure is going to be same. And second property, they are vertically opposite angles here again, right? And so they are going to have equal measures. The angles, exterior angles at each vertex, they are always congruent. That is what our next question is. What it says, are the exterior angles formed at each vertex of a triangle equal? Yes, the exterior angles formed at each vertex of a triangle are always equal. Okay, then what can you say about the sum of an exterior angle of a triangle and its adjacent interior angles? The sum is always 180 degree because they are linear pair angles. That's what I said. This is exterior angle and this angle. This is the adjacent interior angle. So they form the linear pair. Or you can see here, these two. This is the interior adjacent angle and this is the exterior angle. So they form the linear pair. And so their sum is always 180 degree. Okay. So that is the answer for the third. What can you say about the sum of the exterior angle of a triangle and its adjacent interior angle? So the sum of an exterior angle of a triangle and its adjacent interior angle is 180 degree because they are linear pair angles. Okay. So dear students, I hope whatever I have tried to teach here you have understood. If there is any doubt, definitely you try to contact me and discuss it. And most important, you will write the logical proof in your notebook and think, discuss and write questions in your notebook. You will solve them as homework. So today we will stop here. So hope we'll meet. Let us meet in the next period. Till then, goodbye. Thank you.